Hi, this is Paul Nussbaum over at ECPI University, and I wanted to continue our discussion about additive manufacturing, specifically going ahead and 3D printing some things that have some moving parts. But before I talk about the future, I would like to talk a little bit about the past. And I think you'll see some parallels there, but when we talk about the past, we talk about, for example, let's talk about carpentry. How do you build an entire house? So here's a picture of my friend Ed, and he collects old tools, carpentry tools and such. His father was a carpenter, and so he's got it kind of in his blood, if you will. And frankly, his garage looks a lot like a museum. Most carpenters back in the day would take great care in maintaining their tools, because the tools were indeed exactly how they were going to apply their trade. So Ed has made a hobby of collecting these antique tools. So for example, just like you'd sharpen your skills in high school, so too would a carpenter sharpen their saws, because they're going to be going ahead and using those. Here you can see it's a vise to hold the saw still while sharpening it. There were lots of specialized tools. Here's some tools specifically for bending those teeth of the saw, cutting them, and then further sharpening them. So a couple of different tools here used for the carpentry. But it all goes back to that engineering precision lesson that you had a while back, but then you keep seeing recurring, hopefully, in your life again and again. Like that saying from the TV show, This Old House, you should measure twice but cut once. So you really want to be aware of the measurements that you're using. And carpenters back in the day would certainly do that. Here you can see a collection of yardsticks that different hardware stores and building supply stores would give away in and around Richmond. So he made quite a bit of a collection there. Sometimes you needed some help with that measurement. It wasn't convenient to use a yardstick, so these tools assist with measurement. You would put the sharp points either between or on either side with a caliber of something you wanted to measure. Then you can move that over and compare it to something else, like comparing a peg to a hole that you need to put in a table leg, or just bringing it over to the yardstick and measuring the distance between the 2 points. And of course, not just distances, but angles are very important to measure. The most important one obviously being the right angle, or 90 degrees. So you can see some antique right angle measurement tools here. Sometimes we talk about something being straight down or level with the earth, straight across. What do we mean by that? We mean that we do know the direction of the center of gravity of wherever we're standing on the planet. And if we were to drop something, what direction would it fall? Certainly I want to build a house that goes straight up and down from that point. I don't want to build a house that's kind of tilting to an angle, and then we'll have a tendency to fall over. So plumb bobs, these are these weights, usually with a point at the bottom, allow us to make a variety of measurements relating to which direction gravity is pointing. They could be attached to a string and then used with a protractor or a right angle to measure an angle, or they can be pointing to a position far away in the structure that I want to make sure that I'm still right on top of or above in terms of which direction gravity will pull. So these are a variety of antique plumb bobs there. Also, if you notice something, a lot of this manufacturing that we're talking about with the carpentry is not additive manufacturing like a 3D printer where we keep adding plastic layer by layer before we build something. Instead, it's kind of like removal manufacturing. In other words, I would begin with a piece of wood, and then I would remove some of it by sawing it off, or remove some of it by drilling a hole. Obviously, that required a steady hand. You, especially when you're starting the hole, you had to definitely hold this kind of a drill nice and steady. You'd hold that with the top part, the swivel part that you'd hold with your hand, and then you'd rotate around with that center handle to get it to turn in circles. Same thing with these tiny hand saws that were meant for sawing smaller pieces and around curves. Certainly, if you weren't strong before becoming a carpenter, you definitely become strong by the time you're finished. You can see there's a lot of elbow grease involved in using these tools. For more delicate work, you can see some awls are on the right side, but on the left you can see, for example, once the wood has been cut, we might want to remove unwanted bumps or carve away certain pieces. So these antiques you can see here have the blade in the center, and it's pulled towards the user with both hands using the handles on either side. Sometimes the decorative wood piece really needed more of a sculpting approach rather than just sawing or scraping. These chisels can be pushed by hand or slowly tapped with a heavy mallet. The shape and the size of the chisel is custom made for, the specific task and the shape that you want to carve. You can see some of them are straight, some of them are long and narrow, some of them are curved. But sometimes you really just want to make something perfectly flat, like a top of a table or the top of a shelf. You really don't want it to have any kind of curves or bumps to it. For that reason, we'd use a planer, and that's those, they're all lined up at number 5 and number 4 and number 3, different numbers. And the planer has this flat blade on the bottom, and it needs to be scraped many times repeatedly over a piece of wood to make it perfectly flat and level. So there's a curved handle in the back that you kind of push the planer with, and then that knob in the front, that rounded knob, is what you'd hold to go ahead and steer the direction of the planer. Definitely a two-handed job, and it takes quite a bit of time to make an entire tabletop nice and flat and smooth. Sometimes you'd like to use a planer, but you really don't want a flat piece. You want kind of a sculpted piece. But you need that sculpture to be really long and along the entire length of the piece of wood. Some of the examples might be a shoe molding or a chair molding or something near the ceiling of the house. Any kind of decorative wooden strip that might run the length of a cabinets or a furniture piece that we want to carve nice and straight, nice and flat, but with a sculpted edge to it. So you can see that they actually manufactured the tool to make many manufactured items again and again. You'll see that theme repeated with any kind of manufacturing where you're going to be making the same piece over and over again. Why would I want to use the chisels? Why would I want to use the saws and make a mistake or not have it be very uniform? It's better off to make and manufacture a tool that you'll then use again and again to make exactly the same piece over and over again. So in this, he's got quite the collection of these kind of edge molding and different planers here. I've zoomed in on one of them on the bottom here. You can see that the blade is curved in a certain way, and then also the bottom of the planer is also shaped in that same curve, and that'll be exactly the opposite of the piece of wood that's being carved. It'll be kind of opposite in shape to that. It'll cut away and match it perfectly, and that might be used for the edge of a cabinet, the top part of a ceiling, the strip along the wall where the backs of the chairs might bump into, or at the bottom of the wall where feet might kick into, and be a little bit more resilient but at the same time decorative. You'll see that again and again. Manufacturers will first manufacture a tool that will then be used to manufacture the product again and again. Obviously, not everything will be made by the carpenter themselves. They're going to go and shop for additional hardware. So just as when you create things with 3D printers, let's say you wanted to make a self-flying drone. So you 3D print all the parts and the propellers and the different steering mechanisms, but you still might buy the hardware to do the radio control, remote control, and also the motors and maybe even the thing to hold the battery pack. So you're going ahead and adding hardware to your 3D printed item if it's going to involve a more sophisticated motion. And in this case, you can see some antique items, doorknobs, locks themselves. These are going to be added, and they're usually purchased from a separate manufacturer that does the metalworking. Brass was a commonly added item. Here you can see a number of antique brass items, knobs, door handles, lock face plates, as well as the actual hinges. Now, hinges are so important to the motion of the door. It's very important not only to measure that the door has to be slightly smaller than the doorway, exactly this kind of thing we talked about in our earlier lesson, but here we can see that also the hinge itself has to be much stronger than we could make with wood, and will last a lot longer if we make the hinge out of brass instead of wood. So you'd basically go ahead and buy a hinge from a different manufacturer and add it to your wooden door and frame. Obviously, my description wouldn't be complete as a electronics engineer if I didn't mention the electrical components. So here's back around the time when these components were made, electrical lighting was starting to replace gas and candle lighting. And these are actual items removed from buildings, antique buildings here around in the Richmond area as they underwent renovation many years ago. So you can see the kinds of electrical switches and lamps that were being used back in the day. But hopefully this little museum of my friend Ed's helped you see a picture of how the carpenter back in the day really had to use all of the tools. In their case, it would be removing things from pieces of wood and crafting, and then nailing them back together in the shape of whatever building they were working on or fixing. But they also got some parts from other manufacturers to go ahead and put the finishing touches on whatever it was that they were building. So you say, well, that's very nice, that's just the past. I mean, what does it have to do with me and my future? I'm going to work for a large company and I'm going to help them make their products. Really? Or will you be self-employed? Many students in high school actually do think about becoming entrepreneurs themselves. And it's worth looking at the trends in our world and seeing things like Uber, where anybody with a car can kind of act as their own taxi company, or Airbnb, anybody who has an extra room in their house can kind of act as their own hotel, or Etsy, where anybody who can make crafts and custom make things for people can kind of act as their own art gallery. Or Amazon, anybody who has lots of things to sell and is good at buying and selling items can really be their own retail merchant. Bitcoin is even making people act as their own bank. One that I'd like you to look at, which you may not have before, is Alibaba. So Alibaba is primarily in the Chinese markets. It's kind of like an Amazon, but it's like a perfect Amazon for not just people who want to buy things and use them around the home. It's also a great one for people who want to be their own manufacturer. And in China, there are thousands upon thousands of these entrepreneurs who manufacture things and are very good at manufacturing, and they need all these little extra hardware parts to do it. So for example, all of those, a couple of years ago when the electric scooters advanced to be those hoverboards, and suddenly everybody wanted to make their own brand of hoverboard. It made the news because a lot of people used cheap parts and cheap batteries, and some of them didn't work so well. In fact, some of them actually caught fire. But these are people that were able to move so quickly and jump on top of a trend and start manufacturing it. Alibaba is a great site, and it's sometimes things are written in Chinese. You might have to use the Google translator, but it's a great site for people who just want to be their own little manufacturer. So here's just a picture from the Google search, an image search, and the buzzword that I want to teach you on this slide is the word sharing economy. Sometimes all these ones, Uber, Airbnb, Etsy, Amazon, Bitcoin, and also that Alibaba that I want you to look up, they are part of what people call a sharing economy, and it's my personal opinion that this is not going to get smaller. It's actually going to grow larger. So I do want you to think about not only just being an entrepreneur, but also, being able to go ahead and do some work as a self-employed or as a contractor to someone else who wants something done. That's definitely something very much of interest to many students and might actually impact your future career. So we learned about AutoCAD and Inventor. These are software products from Autodesk. And I also demonstrated to you the free version for students that combines all these features. It's called Autodesk Fusion 360. So we learned about 3D printing. We made and used some calibration tools to go ahead and measure 3D printed objects that include motion. And now I'd like you to take it to the next level using this site called Instructables. And their motto is learn to make anything. It's a website that people are teaching each other how to make things at home. 3D printing, but also robots using Arduino controllers and, well, 1,000 other things. Even gardening and cooking is described here, as well as woodworking. All sorts of things are described on this Instructables. So specifically on the Instructables site, I'd like you to set up an account or use an account that's set up by your teacher, however your teacher wants to do it. Definitely the rules of the high school take precedence. And I'd like you to use an Autodesk product. It can be AutoCAD, but it could also be Fusion or the Autodesk Inventor. These are all fine. And what we want to do is enter a contest. And specifically, we want to enter a contest that makes a 3D moving object. So, what do you know? There's a contest running right now. It's called the In Motion Contest. And there are great prizes, and there are things you can win by entering the contest. But I'm not so worried about whether or not you win the contest. I really just want you to have the experience of going ahead and give it the old try, if you will. So do the best you can, and I think you'll really find it an exciting experience. So let's take a look at what your assignment is for today. So your assignment is really these 4 things. I want you to find the details of the contest. So when is the deadline? How are the winners selected? I want you to see how your teacher wants to run the entry or entries. Your teacher in high school is going to have some specific instructions about how they want to do it. I want you to take a look at the competition a little bit, the other contestants, whether they've got some votes already and what's going on with them. And the last thing is I want you to think about what you might enter yourself or as a team, depending how it's going to be organized for your class. But really, we've had some discussions already about some ideas of making a 3D printed object using the 3D printer and additive manufacturing and having that use moving parts. So that's really what we're looking for. But you may also have other ideas or thoughts or Google ideas. And there's also a site called thingiverse.com you can visit. I'm going to go ahead and leave this last slide up for you, teacher, to go ahead and hit the pause button on this video, or just pause this on the screen so you can talk about it. But that's really your assignment. Listen, thank you so much for listening to this lesson and getting a view of Ed's antique carpentry tool collection. I certainly learned a lot when I visited his home, and I hope you got to learn something and gotten excited about returning to a sharing economy here in the United States. I think it's something that may affect your careers going forwards, and certainly can be a lot of fun for us right now with this contest. Once again, this is Paul Nussbaum over at ECPI University, and thank you so much for your time.